Okay, so today for my live, I'm going over percents and rates. And so the topic for percents and rates here are specifically referring to all the word problems that involve percentages and things like that. And so this goes best with the fourth assignment, mini assignment that you guys have, the ones that's on applications, and because that's going to have all the word problems in it. So we put all the word problems in one assignment, so you don't really have to worry about them in the first three. So one of the questions that actually people get wrong on the quiz very often is the word problem related to percents. So that's why I'm going to do this for my lesson. So just to review what a percent is, the word percent, if you split it up, it's literally per cent, and cent means 100 because it comes from the Latin word centum, which means 100. And that's why when you think of cents, we have 100 cents in $1. So that's where that comes from. Per means divide. So if you see the word per in math for a word problem, that means you're dividing. So the word percent is telling you that you are dividing by 100. And what a percent is representing is a proportion of something or a part of a whole. So it's basically a fraction, but your whole is always considered to be 100. So you can have fractions that are like 3 out of 4. That's not considered percent because it's not out of 100. It's a percent if it's out of 100. So that's why 100% is, as full as you can get basically. And any math that we do with percents, we always have to either write it in its decimal form, where you just take the number and divide it by 100 on your calculator, or you can make it a fraction by taking that number and writing it over 100. So if you have like 5%, that's equal to 5 over 100. So can write that. So if you were doing a word problem and they said 5%, you would either in your work have to write it as 5 over 100 or use the decimal form, which would be 0.05. We don't use the whole number part, the part with the percent. You have to use the decimal or fraction form. And generally with word problems, we always use the decimal version. So don't worry about trying to have to do fractions with these word problems. We usually use it as a decimal. So that's key because I see a lot of people forgetting to do that or forgetting to convert it to its decimal form to do all of the math, and then your number is usually off. So it can be a problem when you're doing your work. So to help you out, there are common formulas that you can use when you're doing things with percent. So with sales tax, you're basically to find how much tax you're charged, you just take how much your merchandise is and you multiply it by your tax rate or the percent. And again, you have to multiply it in its decimal form. Commission is where you're earning some percent of your sales, and then that's going to be added to your paycheck. So it's sort of the same calculation. You're taking how much you have and you're multiplying it by your rate or your percent. So you're doing the same operation here. You're taking your total and you're multiplying it by a percent. They just have different names essentially. Then we have a special formula called simple interest. And so that tells you how much interest you get. And so that is principal, and the principal is how much your loan is or how much you're investing, multiplied by your annual interest rate, or usually that's APR, and then how many years you're getting interest or you're paying interest on this thing. And so the formula is usually abbreviated as I equals PRT. What simple interest means is that you're only getting interest once a year and you're not having interest on top of other interest. So most things in real life do not use simple interest. Usually we have compound interest where you're getting for loans, you're paying interest on top of your interest, or if you have money in a savings account, you're getting interest, and then that interest is included when it calculates the next interest. But simple interest doesn't do any of that. It's just interest on whatever the main thing was, and then you just get that much every year, and it doesn't include what you've already earned in interest. These are a couple more formulas that are not actually given in the textbook, but I think are very helpful. And these are the ones that most people mess up. So sales tax, tips, markup. If you're trying to find the cost of something after you've added in the tax, or you're trying to find the cost after tip, this is what you want to do. So this is a proportion. And so the way a proportion works is that, you've got your denominators need to sort of match and your numerators kind of have to match. So 100 is the whole. And when you're adding tax, you're thinking your original price is the whole. So that's why the original is on the bottom. And then on top, we have, okay, what is going to be after we add tax, after we add on tip, or we mark up something, that's going to be in the new price. And so that is equivalent to taking 100, you're taking the whole thing, and then you're adding a percent on top of it. So that's why it's 100 plus your percent. And in these cases, just for these formulas, you don't need to put it in decimal form because these already have the over 100 part. So for these formulas, you don't need to convert to a decimal or fraction because it's already taken care of in the formula. The previous formulas don't do that. So the discount and markdown formula is very simple, or very similar, because it's essentially the same formula, but now you're subtracting, because when you're getting a discount, you're not paying the full 100%, you're paying less than that because you're getting some discount on it. And so you're subtracting, so if you get 10% off, you're actually paying 90% of your price because you're subtracting that 10%. And so the formulas are essentially the same. It's just if you're marking something higher in price, you're adding. If you're discounting it or having a markdown, you are subtracting. So these are the formulas that we're going to use, and I've just got several word problem examples going forward, and I've got some of very different types, so you get kind of an example of each one. So this first one here, Robert can take out a 3-year loan at 8% simple interest or a 2-year loan at 8.5 simple interest. If he borrows $7,000, how much interest will he pay for each loan, and which option will require less interest? So this is a very useful kind of thing when you're thinking about loans. It's kind of understanding how you're finding the interest, how much interest your costs, so you can compare if you've got loans at different lengths and different percentages. So our simple interest formula, I'm going to write this down, is I equals PRT. So I is the amount of interest, P is the principal, which in this case is how much you're borrowing, R is the rate, which is the percentage, and when we refer to as a rate, we're using the decimal version, and then T is the amount of time that you're going to be having for this loan. So we're going to be basically doing two different calculations because we have two different loans here. So we have a 3-year loan, and so we know that our principal for this is $7,000. The rate is 8%, which is equivalent to 0.08 when you make it a decimal. So you're dividing that number by 100. And then our time period is 3. So I'm going to just basically plug it into the formula because we want to know, because the question says, how much interest will you pay? So our formula will tell us how much interest we're paying. So it's PRT, and these are all multiplied. So you're going to have $7,000, because that's your principal. You're going to multiply it by your rate, 0.08. and then by the number of years of the loan, which is 3. And then calculator is necessary because I don't know anybody that it can. If you can do this in your head, I am very impressed because this is something where I'm like, I'm pulling out a calculator. So we get $1,680. So I'm just making sure that I'm including my units there, so that way we know that this is okay. This is the amount of interest you'll be charged over the 3 years for that particular loan. And then we want to do the same thing for the 2-year loan. And notice how I'm color coding here. I like to do that so you can kind of keep things separate. So with the 2-year loan, our rate is 8.5%, which is 0.085. So slightly different with the decimal. And then the time period is a 2-year loan, so it's less. It's a higher interest rate, but for less amount of time. So we're going to use the same formula. Our principal is the same. We have a different rate and a different time. So we have 7,000 times 0.085 times 2. And so that comes out to $1,190. So you can see that it's actually, you'll pay, so the question says, we've got 2 questions here. How much interest will we pay for each loan? So we found that out. And then which option will require less interest? So the 2-year loan actually is less interest because even though it's a higher interest rate, it's for a lower amount of time. So that is better. You know, you don't want to pay interest. You don't want to pay more interest than you have to. So when we have word problems, we usually write our answers in sentences. So like for specifically the option that will require less interest, we would put that as a sentence. So we would say the 2-year loan requires less interest. And then if you want to take into account the other interest, you can say interest is 1,190 versus 1,680. It'd help if I actually spelled interest right there. So this is an example of using our simple interest formula. And this is actually, if you're wondering, well, how do I show work and that kind of thing, this is a good way to kind of model how you show work for things like this. I always recommend for word problems that you write down the formulas you have, then you write down your variables and what numbers you're plugging into them so that you have it there, like I did, P, R, T, I'm writing what those are equal to, and I'm pulling those from the word problem. And then I put those into our equation, and then it's just a matter of doing the math on the calculator. And then it's always good to follow it up with a sentence so that way you know what your actual answers are at the end. Are there any questions on this example? Okay, so I'll move on to my next one. So here we've got a salesperson earns $50 a day plus 12% commission on sales over $200. If her daily earnings are $76.88, how much money in merchandise did she sell? So this one, we can't just simply use our commission formula because you have to think about what's actually going on. And you may be wondering, well, how do you know that? The commission formula just tells us how much she earned in commission. Here, we're not being told that she got $76.88 in commission. We're being told that's her daily earnings, which includes the $50 that she earns flat. So this total, it includes our 50 plus the commission. So we've got two things going on here. So it's good in these kind of situations to kind of write down what exactly you have going on. So her daily earnings, this is equal to the $50 because that's what she gets, and then plus whatever is earned from commission. So it's good to kind of break that down and to take the situation and write down, well, what exactly does this mean? What are her daily earnings being made up of? It's $50, and then it's the commission on top of that. And so this is where we could plug in our commission sale, or our commission formula. So it's going to be $50 plus the merchandise that was sold times the commission rate. And that goes back to that formula for commission. I mean, they have an amount in sales. I just wrote merchandise because that's the word that is used in our word problem. But I'm replacing that commission by the actual formula we have for commission. So I just kind of plug that in, and then that gives us our daily earnings. So sometimes it's helpful to then kind of create variables for this. So that way you're not got all these words. So maybe you want to write this as your earnings being E, and we've got our 50. And then maybe the merchandise is M, and then our rate, we always use R for that percentage. So you might want to maybe, after you've kind of written out in words what's going on, then pick variables to represent things, so then it starts to like kind of turn into math, and you're just literally just replacing what you wrote with the letters that you're choosing. So let's take a look at the information that we have. So we know we've got the $50 per day already taken care of. We've got 12% commission, so that's R. So I'm going to just label that R is equal to 12%. Which is equal to 0.12. So I've got my R labeled. The next thing they tell us is they're telling us the daily earnings. So I've labeled that as E. So our daily earnings are $76.88. So I know E and I know R. This tells me I'm looking for M, because that's the only thing I don't know. So I'm going to start plugging in my numbers. So I have 76.88 equals 50 plus, and when you have a number that you're replacing, we usually put that number in front. So it's going to be, whoops, I put my decimal in the wrong place. Okay, 0.12 M. So now we've got the formula that we're solving here, and we're solving for M. So when you're solving, you want to get your variable by itself, and you always do any addition or subtraction first. So I need to move the 50 away from the side that has the M, and I need to move it to the opposite side. So you always do the opposite. So because it's a positive 50, that means I'm going to subtract it away to get it to 0. So I'm just going to subtract 50 from both sides. And I'm doing this in a different color so that you can see that it's different from what my original equation was. So I'm going to just pull out my calculator and subtract 50. And we get 26.88 equals 0.12 M. So now I've got this number in front of the M, and the 0.12 is multiplied by M. So to get rid of it, we divide it. We do the opposite. So we always write that as a fraction. It's just generally how we write our work here. So we're going to indicate that we are dividing both sides by 0.12. And this gives me 224 equals M. So M is the amount of merchandise that was sold. So the question says, how much money in merchandise did she sell? She sold $224. And so we'd want to then kind of summarize that up. And you would say she sold $224 in merchandise. Just to kind of put that number in context so that you know what that means.
Professor, did you say multiplying the 2688 times 0.12?
We're dividing it by 0.12.
Okay.
Yeah, so because the 0.12 is multiplied by m on the right, to undo it, we divide. And so we have to divide both sides. And when I write it the way that I do with the line and then I'm putting the number underneath, that's indicating division because fractions mean division. So I write it as a fraction, and that says you're dividing these things. Are there other questions? Okay. So I will move on.
Actually,
We've
I
got.
have a question.
Yeah, go ahead.
So in your description up here, it says 12% commission on sales over $200.
Oh, good catch. Good catch. So I didn't even notice that. Good catch. So that will cause us to kind of modify our formula differently. So let's see. So the merchandise sold, it's only over 200
For the commission.
for the commission. So this is a good example. We'll do the problem a second time with this so you can see the difference here. So to do that, the merchandise, we have to subtract 200 from the cost of the merchandise before we multiply the commission rate because it's only the stuff over 200. So what that changes with this formula here is that it's going to be m minus 200 and then multiplied by the rate. So I will just keep changing. So then this m minus 200 instead of m. So now the process is going to change. So I need to erase everything that I've got here. This is a very good catch. I just kind of missed that in my own reading. Very easy to do. I mean, these are things that got to read carefully. Even I can make mistakes. Okay, so I've modified our formula so that we're subtracting away the 200 that we're not earning commission on. And that's indicated by, in parentheses, m minus 200. So our solving here is slightly different because we need to distribute first. Anything you need to multiply or distribute happens before you start doing things on both sides of the equation. So I need to multiply the 0.12 through my parentheses here. And I have to multiply it by the m and the 200. So our next line is going to be everything on the left is staying the same. We're not doing anything to that. We're not changing the 50. We're going to have 0.12 times m, which will just become 0.12m. And then 0.12 times a negative 200. So I'm going to pull that up on my calculator. That gives us a negative 24, which is the same as subtracting 24. So if you write, like it says minus 200, you're subtracting 200, that's the same as a negative. So I just put a plus between each of these, and then if it's negative, I put a negative sign there. So we've got 76.88 equals 50 plus 0.12m plus negative 24. So we need to actually add the 50 and the negative 24 together before we start doing anything else. So that's going to be basically 50 minus 24. So I get 76.88 equals 26 plus 0.12 m. And now we're going to start the solving process like we did before. So we're going to subtract 26 from both sides. So 76.88 minus 26. Oops, I hit the wrong button on my calculator and I accidentally multiplied. That gives us 50.88 equals 0.12 m. And now we're going to divide both sides by 0.12. And we get m equals 424, which actually is $200 more than the original way that we solved it. So I suppose what we could have done is then added $200 to our number that we got in our original problem, because the first 200 didn't count. So that's one way that so now you've seen two ways to do the problem. You can do it the first way we did and then add 200 at the end because that first 200 doesn't count. Or you can include that 200 or kind of write your formulas so that you're taking care of that and then you're getting the total at the end. So she sold $424 in merchandise. So are there any questions? Are there anything else that I might have missed? Did I do my math wrong? It's possible I plugged something in a calculator wrong. Is there anything that it looks like I might have missed or that you have questions on? Okay. So this example, we've got Wayne County has a sales tax rate of 7%. How much does Mike's used car cost before tax if the total cost of the car plus tax is $13,888.60? So this is going to be one of the proportion formulas that we use because the price is marked up due to tax. Tax is added on to it. So we've essentially got our new price, which is the price after tax, and then the original price. And then we have 100 plus our percent over 100. So that's going to be the base formula that we're using here. And so this new price is going to be after tax. And then the original price is going to be before tax. So the total cost of the car plus tax, that's the new price. That's what we know. So we're labeling this as new price. And we've got the percent, which is 7%. So I'm going to fill this in. We've got 13,888.6. And then you're going to pick a variable to represent the original price of the car. So maybe we'll use C to represent car. Then this is going to be equal to 100 plus that percent. So we're going to add 7 because for this formula, you don't need to convert it to a decimal. And then 1 over 100. So this is a proportion, and the way that you solve proportions is by multiplying the diagonals. So it's cross multiplying. So you're multiplying these together, the 888.6 by 100, and then multiplying the other diagonal together. So what this looks like is that we've got our 13,888.6 times 100, and then you still have an equation. So you've got your equal sign in between there. And then it's C times 100 plus 7. So on the left, I'm going to multiply that out. I got 1,000, not 1,000, oh, let's see, 13,888.60. It is $1,388,860. And then we've got 100 plus 7, that's 107. So we get 107C. So now you're going to divide both sides by 107 because we're solving for the cost of the car, and that 107 is multiplied, so we're going to divide both sides by 107. So you want to make sure you don't miss any numbers when you put it in your calculator. And we get $12,980 for the cost of the car. So you know you've done something right when your cost of the car is, less than the amount per tax. You do want to make sure that your numbers make sense. If I got like 15,000, then that wouldn't make sense because the cost before should be cheaper than the cost after you add on tax. And so Mike's used car cost $12,980 before tax. Now, what I've seen some people do is that they will take 7% of the $13,888.60 and then subtract that from that amount. That is incorrect because 7% of the 13,888.6 is different than 7% of 12,980. So you can't find 7% and subtract it. It's not going to give you the correct answer because percents don't work that way. Percents are not a flat rate that you add on or subtract. They're multiplied and divided. So you have to set it up this way in order to figure out the cost before you add something on. Otherwise, you're going to get the wrong answer. Are there any questions? Okay. Here's one where we've got a markdown. So it's going to be similar to what we did, but now we're going to be subtracting. We've got the price of a used textbook after a 35% markdown is $29.25. What was the original price? So we're still going to have new price over the original price. And for markdowns, you're subtracting your percent. And then that's going to be over 100. So the new price, that is the marked down price. after you did something to it. We marked it down by 35%. So when we plug in our numbers, we're going to have 29, 25 over, and then we're looking for the original price. So maybe I'll just use P for price. You can choose whatever letter you want. And then it's going to be 100 minus our percent. So it's 100 minus 35 over 100. So again, with this type of formula, we don't need to convert it to a decimal because it's labeled as the percent versus rate. You want to make it a decimal. So again, we're going to cross multiply, and if you want, you can do the 100 minus 35 before you cross multiply if you find that easier. So we can rewrite our formula as 29.25 over P equals 65 over 100. So it doesn't matter which diagonal you multiply first, because they're just setting them equal to each other. So we'd have P times 65, which is 65P, equal. And then the other one is 29.25 times 100. And a lot of people will just do that right away. Just do the multiplication on their calculator and then write down that result, which is 2,925. So you can do that rather than writing the step of when it actually multiplied. It's up to you, when you're taking notes, what steps you need to write down. If as long as you don't skip important steps like writing down the formula, but sometimes you can skip some of like the multiplication steps if it's kind of obvious what you're doing there. So we've got 65P equals 2,925. And so we're solving for P, so I'm going to divide both sides by 65 since that's multiplied. Okay, and then that comes out to 45 when I've got my calculator. So that tells us that the original price was $45 before it was marked down. So the original price of the textbook was $45. This is another type of problem where I see a lot of people find 35% of 29.25 and then add that back in. That doesn't work because 35% of 29.25 is different than 35% of 45. So you can't multiply your percent by your number and then try to add her back in. Just like on the previous example, we couldn't subtract it out. I see a lot of people doing that, but that's not going to get you the correct answer. There any questions? Okay, I've got two more examples here. This one's a little more complicated, so we're going to have to do some thinking through here. And so if I miss something, let me know. Suppose that a bookstore buys a textbook from the publisher for $80. At what price should the bookstore mark the textbook up, or mark up, I missed a word there, so that it may be offered at a discount of 10%, but still give the bookstore a 35% profit on the $80 investment? So, I mean, this is the kind of thing that you may actually, if you decide to own a business, you need to figure this out. How much can I discount and still make money? How much can I increase the prices? Like, you got to kind of figure all this stuff out. And so we have to kind of think through what's going on. And so I like to write this just kind of, so we've got our textbook, the publisher price. So just going to write that down. We've got our publisher price. And then we want to mark that textbook up by some amount. So when we mark it up, you know, we're going to be increasing it. We're going to be marking that up. So let's see, I'm trying to think the best way to write this out. So I'm actually gonna, let's see. This is one of those things that you think through and you're trying to like, how do I write this? So let's say we've got the marked up price. I'll just do that. So we have the marked up price already. We want to be able to offer a 10% discount on that. So like we want to be able to do a 10% discount. And then we want our result to be a 35% profit over the $80. So that's kind of what's going on here. This is not how we're going to directly translate it into a mathematical formula. That's just kind of describing what's going on, is that we're going to mark up the price by some amount, so that way when we do have a 10% discount, we're still going to make 35% on whatever that $80 is. So I'm thinking through. So what you may notice is like unlike what some people do when they teach, you know, they may have everything worked out beforehand. I chose these harder problems and I deliberately did not work them out ahead of time so that I can show you the thinking process when you go through it. Because the thinking process is just as important as doing the problem. You need to figure out, well, how am I supposed to think about a problem like this? How do we go about solving this type of problem? So that's what's going on here. I'm going through the thinking process out loud to you guys so you can kind of see how do we do this. So let's see, I'm just kind of reading through it again, and this is something that you need to do, is just read through the problem multiple times often. We want a 35% profit on the $80 investment. So let's figure that out first, because we can figure out how much money that we want after the discount to be in order to get that 35% profit over the $80. We can figure out that much. So I'm actually going to add an extra blank slide because I have a feeling that I'm going to need extra room for this one. So I'm going to start by doing this piece. We're going to do this in little pieces based off of what, you know, kind of section by section. We want to be able to do a 35% profit over the $80. And so this is very similar to the markup type of problem that we had. So we want to know whatever our new price is. We paid $80, so it's going to be over the original price, which is $80. We want to be able to mark it up by 35%. So I'm kind of using that formula to figure out, okay, after the 10% discount, what are we going to sell this for? That's going to be what we have considered for our new price here. Is going to be the price after discount. So we just kind of label that here. Because if you notice on what I've kind of written out in words, the part on the right is after we applied the discount. So that's what I'm going to be solving for here, is not going to be the price we're going to sell the textbook at. It's just going to be the price of the textbook after we did that discount. So maybe I'll use the letter D to represent for like discounted price. So I'm going to have D over 80. then 100 plus 35, so that's 135 over 100. So we're going to solve this, and this is going to give us the discounted price, which is halfway to what we need. So we're going to have one diagonal that we multiply together. That's going to give us 100D. And then we're going to multiply 80 by 135. $10,800. So I'm actually going to rewrite that in my blue, so my color coding is consistent. So we've got 100D equals 10,800. And now we are going to divide both sides by 100. And so that's going to give us D, which is the discounted price, which is going to be $108. So this is after discount. Now the question is not asking for how much it would be after the 10% discount. It's wanting to know what would be the price originally before you do that 10% discount. So now we need to do this same sort of process, but now we're going to have different numbers. But it's going to be a similar formula, but we're going to be using the discount formula. We're going to do 100 minus 35. So we're going to again have, in this case, it's going to be the discounted price. No, discounted price over our original price. And the discounted price was after a 10% discount, so I'm going to subtract 10 over 100. So our discounted price, that's what we just found, the 108. So we have 108 over, and then we're looking for the original price of what we're going to mark up the price to. So maybe I'll just use M for marked up price. And then we've got 100 minus 10, which is 90 over 100. So again, I'm going to multiply my diagonals to solve this. So we're going to have M times 90. So that's 90M. And then we have 108 times 100. Whoops, and I just became a little dyslexic. You got to watch where I put my numbers. So that's 10,800. And then I'm going to divide both sides by 90. We get M equals 120. So that is going to be the price that we are going to mark the textbook up to. So that way, when we take a 10% discount, we're still making a 35% profit on the original $80. So I'm going to write that. So we need to mark up the textbook to $120. And you can kind of check yourself to see, to see like, does this make sense? Did I kind of do some math right? So you can kind of do a check by going through the process. Say, okay, we're going to do a 10% discount on the $120. And so that would be $12 off. So you can just kind of go through it. Okay, 120 minus $12, that gives us 108. Now we want to make sure that's a 35% profit over the $80. So one way you can check that is if you do 108 divided by that $80, we should get 1.35, which tells us if you convert that to a percent, that's 135%. That's indicating to us that we make back the 100 on the 100% of the 80 plus an extra 35% profit. That's essentially what that is saying. So you can kind of double check your math afterwards by going in the proper order and make sure that your numbers are working out the way that they're supposed to, and that you do end up with something that is 135% of what we bought it at, which is the amount of, profit we want to make. And if things like this don't quite work out, then you have to kind of figure out, okay, where did I go? Where did I mess up in my order? Or did I make a mistake on my assumption? Did I use the wrong formula? Because this is a complicated problem. You have to kind of do multiple steps at once. And you have to I had to first kind of write it in words what's going on before I could directly turn it into the formulas that I wanted to use. Are there any questions? I will tell you that this type of problem is more complicated than what you would see on a quiz. For a quiz question, you'd see more of something like this, or maybe something similar to this one. You're not going to see like a multi-step problem like this on the quiz, though you could see something like this on the homework. We try to keep the quiz questions a little simpler than you might see on the homework or in the book. But this is more of like what you would be doing kind of in real life. A little more complicated algebra. So I don't think I really have enough time to go through my last example, because I think that one's going to take a while. And I don't like to make these more than an hour, basically class length. If you were to sit in class in person, that's about an hour. I don't like to keep them too much longer than that. So I will call this good here. And everything that I've written down here on this document, I'm going to save it. And then when I email out the recording, I'm going to include this file. So if you were taking notes and you missed something, or you maybe wrote your notes differently than what I did, you can have this also as a reference. So I do make sure that everybody has a copy of everything that I wrote. You can print it out. You can do whatever you want. And I'll get that out probably within the next hour. So I make sure it processes, add it to YouTube, and then I'll add it to the classroom. So are there any questions on anything before we call it good?
I got a question for you when folks are done here.
Sure. I'll stop the recording then.